Section 1.3 covers variables, expressions, and equations. Really, this is the first section that gets into the study of algebra. We'll talk about defining a variable and finding the value of an algebraic expression, converting phrases from words to algebraic expressions, really a key concept when we get into word problems, identify solutions of equations, identify solutions from a set, and distinguish between an expression and an equation. So let's talk about defining a variable. What is a variable? Well, if you think about the word variable and the root word from English, I think of the word varies. And so when we say something varies, we say something changes. And so a variable is a letter that is used to represent a value that changes. A letter that represents a value that changes. The most common variables you're probably familiar with are x, y, and z. We can also use any other letter of the alphabet. You can use Greek letters if you like, whatever letter. If you've seen the symbol like theta is also a variable, anything like that. So when we talk about finding the value of an algebraic expression, we're talking about given a particular value for the variable, plug it into the algebraic expression. An algebraic expression is just a sequence of things that are added, subtracted, multiplied, divided. Plug the value in and then use the order of operations, so that's going to come back into play from section 1.2 to simplify that resulting numerical expression. This problem here says to value if for part A, x is equal to 4, and then again for part B, use x is equal to 6. So here you see the value of the variable changes, so that's why we call it a variable. We'll start pretty easy. Number 13 is to find the value of x plus 9 when in part A, x is equal to 4. So what we want to do is replace the variable x value 4. So this is going to become 4 plus 9. And 4 plus 9 is 13. In part B, the x plus 9 has a value of equal to 6. So here we're going to replace the x with 6. Then everything else is constant, so that doesn't change. 6 plus 9 is 17. Let's go to is to find the value of 4x squared when x is 4 and then x is... So when x is 4, we're going to do this. 4 in parentheses, we're going to replace the x with the value 4. But everything else stays the same. Now what would the order of operations say? This is really 4 times squared. If you remember, x takes priority over multiplication. So I would need to find, first of all, 4 squared. 4 squared is 16 times 16 is 64. It's equal to same thing, just now replace my x with the value of 6. 4 times, that's 4 times 36, right? 6. And what is 4 times 36? 44. Okay. Now, these are all very similar. The problem is just a bit different. Number 19 is a fraction, but I can still do that. Number 19 is to find the value of x plus 1 over 3. Well, in part A, I'm substituting the value 4. So this is going to become 4 plus 1 over 3, or 5/3. For part B of that, I would just the x with 6. 6 plus 1 over 3 is 7/3. So that's what it means to find the value in an algebraic expression. You have to be told the number to plug in. Once you plug it in, you just use the order of operations to simplify. Now there can of course be more than one variable. Like in these examples, to find the numerical value if in part A, x is 2 and part B is x is 1 and y is 5. So notice in these problems there are two variables, the x and the y, so we have to be told two different numbers. So I won't do all of these, but let's just look at a few of them. Number 27 is to find the value of 8x plus 3y plus 5. So here this is 8 times x. Well, what is x? X is 2. Then plus 3 times y is 1. And then the rest of that stays constant. So using order of operation, 8 times 2 is 16. Times 1 is 3 plus 5. So adding from left to right, 16 plus 3 is 19, plus 5 is 24. I won't do it with the other values, it's the same method. Let's look at number 37, for instance. That is 2y squared plus 5x. Let's do it this time. X is 1 and y is 5. So what just go through, put parentheses in. You see the variable and then plug in the numbers. So we have 2 times what is y? It is 5 squared. Plus 5 times what is x? It is 1. So the order of operations tells us to do the exponents first. So this is really 2 times 5 squared is 25. Plus 5 times 1 is 5. So we really get 50 plus 5 or 5. Okay. Now objective 2. Probably one of the most important objectives you're going to talk about in this course, to convert phrases from words to algebraic expressions. So this is where you need to know the key phrases and what those represent. Some of the key operations that you know at this point are adding, subtracting, multiplying, and dividing. There are key phrases in English that translate to these mathematical symbols. So we'll look at some of these here. For instance, in number 43, 12 times a number. So if we're going to use x as our variable, a number we don't know, but times is multiplication. So in number 43, 12 times a number would be 12x, right? Many ways to write that. You could do 12 parentheses x, or 12 in parentheses and the x in parentheses, or also 12 dot x. I would not to use the x symbol for multiplication because that would be very confusing, but the most common way to write that is when you have a number times a variable. It's just those written together with no symbol separating them. What about number 46? 13 added to a number. So 13 added to something. If we start with our number, we add 13 to it, we get x plus 13. 13 plus x is also correct. What you add doesn't matter, but the direct translation is saying 13 added to something, so that would suggest the addition comes last. These numbers got cut off. I apologize for that. Let's do number 48 so that you can see what I'm talking about. Number 48, 8 subtracted from a number. So subtracted from means if we have our number, and from that we're going to subtract the value 8. Do not confuse this with 8 minus x. That is not the same thing. Not subtract. and change the order. So subtracted from means we're starting with that number, then subtracting 8 from it. Okay. Now what about 52? The difference between 6 and a number. When written in this form, the difference between two things means subtract those things in the order in which they're written. So the difference between 6 and a number just simply means to do 6 minus the number, which is x. Number 54, let me change colors just so it's not confusing here. A number divided by 12. So our number is x divided by 12. This is a good one to look at. Of 9 and 5 more than a number. So the product of 9, what does product mean? Product means we're multiplying. What two things are we multiplying? We're multiplying 9 and is separating what we are multiplying. So none of our factors, multiplication, and then 5 more than a number is another factor. So here we have to write this as 9 times other expression. Very important to have parentheses here. If we don't have parentheses, it doesn't connect the multiplication of 9 to the whole expression that we're talking about, which is 5 more than a number. To do 5 more than a number means we have our number. 5 more than that means we're adding 5. Okay? Another phrase that's not in here, but I just want to make sure you understand it. What if we had the expression that we needed to translate 1/2 of a number? One half of a number. Like for instance, if we had 1/2 of 6 would be 3. The word of means multiplication. So 1/2 of a number means we're doing 1/2. Not. Let me erase that. Not 1 x. 1/2 of a number means we're doing 1/2 times a number. 1/2 x. You'll get more into these later on as we go through the course, but just a real initial introduction to those. The next objective is to identify solutions of equations. Now, chapter 2 is how we solve equations. So you're not even worried about that right now. You're just looking at if you're given an equation, you're given a number, determine if this number is a solution. So first thing you need to know is what does it even mean to be a solution to an equation? Okay, a solution is a value of a variable or of the variable that makes the equation true. Or some books will say the value of the variable that satisfies the equation. Make it true means the left side is equal to the right side. So in number 59, all I need to do is determine in this equation 5m plus 2 equals 7. Is value 1 a solution? So in other words, it's 1 the value of m that makes this equation true. So I'm going to check if m is equal to 1, what happens in this equation? I would get times 1 plus 2. So I'm asking myself, is that expression equal to 7? Well, if you use the order of operations, we know 5 times 1 is 5, plus 2, and of course that equals 7. So in this case, 1 is a solution to the equation. Let's look at number 61. 61 is the equation 2y, 3 times in parentheses y is 2 is equal to 14. I'm sorry, is equal to 14. We're trying to find out if y equals 3 is the solution. So when we replace our y with 3, so everywhere we see the y in the original equation, we're plugging in the value of 3. And we're trying to find out if that expression is equal to 14. Using order operations, first of all, we can do 2 times 3 is 6, plus, then in parentheses, 3 minus 2 is 1. So do multiplication first to get 6, 3. Is 6 plus 3 equal to 14? No. 9 is equal to 14. So this is a false statement. So since it's false, we know that 3 is not a solution. Now in chapter 2, we're going to find out how to determine what the solution is. We're just determining is that value a solution. So this is in process through all of these problems. You're just going to plug in the number that's given. If the equation is true, then the number you plugged in is the solution. If the resulting equation is false, then the number you plugged in is not a solution. The next objective is very similar. It is just find all the solutions from this set, the word statement for an equation, and then determine all the numbers from the set that might be solutions to that equation. So it's going to kind of review the skills that we talked about previously today. So in number 69, it says the sum of a number and 8 is 18. Okay, so what I would suggest that you do, first find out what word separates the left side and the right side of the equation. So is means equals. So that means on the right side of that is going to be what's on the right side of the equation. On the left side of that is going to be the left side of the equation. So on the left side, we have the sum of a number and 8. Sum means addition. So we're going to have the sum of a number and 8. So our number is x plus 8 is 18. Now at this point, we're not talking about how to go through and solve it, but just to determine if there are any solutions to this equation from the numbers 2, 4, 6, 8, or 10. So if we plug in 2 plus 8 is 10, which is not 18. If we plug in 4 plus 8 is 12, which is not 18. If we plug in 6 plus 8 is 14, which is not 18. If we plug in 8 plus 8 is 16, not 18. If we plug in 10 plus 8 is 18, so that makes that true. So the only solution from that set is that x equals 10 is a solution to that equation. Okay. Let's talk about number 73. That's a pretty cool one. 73 to translate is 1 more than twice a number is 5. So here again is our is. We know is 5 means equals 5. 1 more than twice a number. So the 1 more means that 1 is added to something. What is added to? Twice a number. Twice a number means to multiply a number by 2. People write there x squared, but x squared, it would have to say 1 more than the square of a number for it to be x squared, but twice a number just means to multiply by 2. Now then I'm just looking at from this set of numbers which one is a solution, which one makes it true. If I plug in 2, notice that 2 times 2 plus 1 is 5, right? Because 2 times 2 is 4 plus 1 is 5. So that one is a solution. 2 is a solution. You could do the other numbers and not going to work, but I'll just show you one more. 2 times 4 plus 1 is that 5. That's 8 plus 1, which is 9. So that one is not a solution. Okay. The next objective, just to distinguish between an expression and an equation. An expression has no equal sign. An equation has an equal sign. Okay. So, for instance, which one of these are expressions? Well, the only expressions, number 77 has no equal sign, so it is an expression. 78 is an expression. And then 82 is an expression. Notice all the others have this equal sign, so they're equations. I like the few exercises that were at the beginning of the section in the textbook. Now again, you don't have to do the textbook exercises. It's pulling here to get you seeing that there's more problems, and you can access these in the when you go to the chapter link in the section. Then the practice end of section exercises, these aren't tracked into the grade book, so you can do these if you want to see what the sections would be from the printed textbook. But these were pretty good, kind of a review of all the objectives that we talked about. Number 1, if x is equal to 3, then the value of x plus 7 is what? Yeah, 10, because that would be 3 plus 7, which is 10. If x is equal to 1 and y is equal to 2, then the value of 4xy is 4 times x, which is 1, times 2. So if you just multiply those, 4 times 1 is 4, times 2 is 8. The sum of 12 and x is represented by the expression. Sum means addition, so that expression would be x plus 12. And then if x is 9, what is the value of that expression? So then we would just say 9 plus 12, which is 21. If x can be chosen from the set 0, 1, 2, 3, 4, 5, the only solution of x plus 5 equals 9 is, well, you can kind of think of this. What number do you have to add to 5 to get 9? Well, that would be the number 4. Will the equation x equals x plus 4 ever have a solution? What do you think? Yeah, it is not going to have a solution because inside you're looking at the number, but on the other side you're looking at the number added, 4 added to it. So those two things are never going to be the same. Right, if I plugged in 1 on the left, x is 1, 1 plus 4 would be 5. So the number on the right is always 4 more than the left. So this will never be a solution. We'll talk about those in chapter 2. Those are contradictions. 2x plus 3 is what? An expression? Yeah, it's an expression because it has no equal sign. 2x plus an equation because it has an equal sign. The last few ones, just some steps here. Explain 2x cubed is not the same as 2x times 2x times 2x. Well, number 7, the only thing that moved is the x. The 2 times, if you remember order of operations, you would just apply the cube. First, cube only goes to the x. For it to be 2x repeated, it would have to look 2x in parentheses cubed. That one's 2x times 2. Number 8, a triangle less than a number, and 5 is less than a number translated differently. Okay. 5 less than a number means we start with a number, and less 5, that would be x minus 5. But 5 is less than, talks about one of those inequalities from the previous section. 5 is less than a number. 5 is less than x. Okay, number 9 kind of goes back to number 7, but it's explained when evaluating the expression 4x squared for x3 squared before multiplying by 4. So we evaluated 4x squared when x is equal to 3. In order of operations, we have to do x multiplication. So this would be really 4 times 9, which would be 36. Number 10, value of would cause 2x plus 3 to equal to 9. That's my pet one right here. And think of this. What number do we have to add 3 to get 9? That's 6. This expression right here, 2x, has to be equal to 6. So what multiply by 2 to get 6? Well, that is 3. And we're going to those, but that would be the answer. Okay, we'll stop there, 11 and 12 right now. Okay, if you have any questions on this,